Hi, I'm just looking through these photos. K&H has said what to do to make the concrete structurally adequate, and I'm assuming that our part of this is just the geometry and the shape of the concrete casements. So this is the valley beam. It appears this is at the curb, but I can't be real sure. This would be that same valley running up as you get to a purlin or a jack bar. And this is just looking straight down. It would be really nice to see what's going on in this area. So in order to answer these questions, I need to explain a little bit about the geometry involved, just so you guys have a chance to build this inclined surface correctly. This is not the pitch of the skylight. It's similar to it. And it's common in skylights, but it's going to be a little bit odd to anyone else. So that's what the reason of this video is, because we do need that inclined surface. This width is very close to what we figured it would be, but it has an inclined surface that's important to support the skylight. So if we look here, you'll see this is the detail going up the valley, and there's the inclined surface in that detail. And you can see the gutter kind of dumps out like this, or steps down. So what I'm going to do is I have this model of the structure, which is kind of theoretical. And this surface is, where do I start? Okay, let's go back to the typical section. This is at the slope of the glass along the header and the purlin. And when you get to a certain point near the corner, that surface goes up 3 inches. And then it goes again following that same plane. Here's the purlin. It goes the same, jumps up 3 inches, goes across. This is the steel angle at the curb. It's also tipped in that slope of the glass. And that runs through, and I believe it miters, but I've never actually seen it. So if you have a picture, it would be interesting to see what's going on right about here. So we're kind of assume the angle would run through. I know there's some kind of frame in here supporting the valley. And if you look here, the incline, so I've faked in, let's call it a jack bar coming down. And when it cuts off, this surface is coplanar with that surface, and with this one, and up here at that one. So let's go back to the photo, and you can see here's an inclined surface. This kind of got eaten away, but that's also going to be inclined. And to figure out what that angle is can be a little tricky. I can calculate it if I know the exact pitch, but we're kind of guessing. I think you're better off taking your cues from these surfaces here and making this little ribbon in plane with these 3 surfaces, here, here, and here. And then when you come down to the curb and it strikes off at the line of the curb for the intersecting skylight, you'll find that it cuts off a horizontal line, so it'll measure 3 1/4 from the top of the angle to the top of that little riser. So that's what's important. We probably have anchors in the first couple inches down here, so we do need this to run down near this angle. It would be helpful to see, because we had to guess. We cut, in this area here, but we couldn't see what was over on this corner. It just wasn't possible to do. It also might be good to look and see what happened up here, if that's all exposed now and you can send pictures. So rebuild the curb surface, set the angle to match these 2 angles, and you could probably measure off this side with a protractor and get that angle. Going back to our detail, you'll see this pitch is not the 23 degrees on the skylight. Let's see if I can measure it here. It's going to be closer to 16. but go by what's on the concrete that you're actually seeing. And then build it out all the way down to the curb, because we're going to cantilever our stuff off the end. So we have that. And these are the connections as we go up the valley. So at every bar we've got anchors going in. And even down here we're going to cantilever off the end of that concrete valley piece with the inclined surface. And we've got these two screws back there that are going to anchor it as it just cantilevers over the end. So hopefully that gives you an idea. We call it a cross-plane angle. That won't have much meaning to you guys. You just want this surface to be coplanar with that, so that if you would lay a straight edge on here, it would bear on this surface as it went past, and it would also bear on this one and on that one, and then just carry that down. And when you strike it off on a horizontal line to go with the curb, you should get a consistent height. And you'd have 3 1/4 over here as well. I will rotate this around a little bit, and you can maybe get a little picture. Hopefully the theoretical model helps make a little sense out of things, separate from all the field conditions that you're looking at with the old concrete. But you can see how they're all in a plane. But it's not an angle that you would know by measuring here. It's complementary to that. And I hope that helps explain what we need, but we do need this little parapet to attach to, and we need it to be planar with these other surfaces. I hope that helps, but at least if nothing else, it gives us a common point of reference. So give me a call and we can talk about it as well.